Welcome to today's Oracle Machine Learning Office Hours feature highlight. Our topic today is data and model monitoring in autonomous database from our speakers Miles Novotny and Sherry LaMonica. I'm your host, Mark Hornick. Now this session is a preview of features that are coming soon as part of Oracle Machine Learning services. Now, monitoring, as you might know, is an important part of an organization's overall MLOps requirements. And the ability to monitor significant changes in data, as well as the models that are built from them, enables you to proactively address issues before they significantly impact your business. So Miles will start off with an introduction to this feature, and Sherry will demonstrate the use of REST endpoints that support data and model monitoring. As always, if you have questions, please post them in the Q&A and we'll address them during the session or at the end. And we also welcome Boriana Milanova, who leads the development effort, who is also on hand to address your questions. Now, since we're discussing soon to be released features, this is Oracle's standard safe harbor statement. Before we begin, let's take a quick poll to understand your familiarity with the monitoring topic. Have you monitored both data and models in past projects as part of your solution deployment? Perhaps you've monitored only data or monitored only models for your projects. Are you familiar with the concepts but have never used them? Or are you just interested to find out what data and model monitoring are all about? So if you'll take a moment and respond to the poll, we'll provide some feedback on that in a moment. Give a few more people a chance to respond. It looks like we have about 12% have monitored data before, but some folks, I'd say over about 60% are familiar with the concepts but have never used them. Another set are, they're interested to find out what these concepts are all about. So about half of you want to understand this in more detail. Thank you very much for taking our poll. And with that, it's over to you, Miles and Sherry.
All right, thank you for the introduction, Mark. Again, my name is Miles Novotny, and I'm excited to be here with Sherry today to talk about these new upcoming features for Oracle Machine Learning, being data and model monitoring. So let's jump right into our agenda for today. I'm going to start off by talking about what data and model monitoring are and why they're important. Then I'm going to talk about these concepts in the context of OML services and how that works. Then I'm going to hand it off to Sherry, and she's going to give us a demo of using these features in OML services. And we'll finish off with some Q&A. So before we start talking about these concepts, I want to contextualize where these things happen in the machine learning lifecycle, right? So data and model monitoring happen where what a lot of people would consider to be the end of the ML lifecycle is. We know it's not the case. This is a continuous cycle that happens over and over again. But it's important to understand that the concepts we're talking about today happen after deployment. These are for models that are deployed, solving some business problem, and we're looking to monitor them. Okay, so we're going to start by defining some terms related to data and model monitoring. And we're going to start with data drift. It's a pretty self-explanatory term. We're just looking at gradual changes in data over time. And this is something that is really just quite unavoidable in the real world, right? The world is dynamic, things are always changing. Your data is going to change over time for one reason or another. Looking at some of the main reasons this could happen, maybe you have a changing business environment, you have legal or government or economic changes happening. Evolving behavior is a huge reason for data drift. People are always latching onto some new trend, some new fashion, new food, new form of entertainment. That's always changing. So what people prefer is really dynamic. You could also have data quality issues, changes in the way that you're recording your data that lead to incorrect or missing data. Also, your data processing pipelines, for example, mechanical sensor wear and tear could cause your data to drift. So those are just a few of the ways that data drift can happen. Again, there's any number of reasons in the real world that your data might change. So that leads us into what is data monitoring. Again, a pretty simple term on its face. We're just looking to track data over time to monitor if that potential data drift is happening. So how exactly do we define data drift? We start with a baseline set of data, and then as new data is accrued over time, we look to compare the baseline and new data to see if there's any change in the makeup between these periods. A great way to think about it is in machine learning terms. So, could we build a machine learning model to predict if a given row of data belongs to the baseline data or to the new data? If you can build that model and it can predict accurately between the two time periods, then you've seen a significant amount of data drift. If it can't predict well between the time periods, then you've seen less drift, right? So looking at exactly how we measure drift, for Oracle machine learning, we are looking at changes in the interactions between pairs of variables. So this goes a level deeper beyond just looking at the descriptive statistics of variables, right? And we're looking at the way these variables interact with each other, which is great because it helps you understand drift that might not be apparent from those descriptive statistics. Maybe the values are similar, but the way the different columns are interacting is different. So in looking at those bivariate interactions between variables, we need to focus on interactions of interest because as the number of columns in a data set grows, the number of bivariate interactions between those columns grows exponentially. So it's not practical to look at all these interactions. So our data monitoring model will focus on key interactions of interest to look for drift. And it'll give you a score of the drift of your data on a 0 to 1 scale. And this scale is based on the accuracy of a model predicting between your baseline and your new data periods, like I just mentioned. It's looking at the AUC measure of that model, predicting between the periods, and it maps that AUC onto the 0-1 scale. For example, an AUC of 0.5 would mean no discrimination is possible between the time periods and give you a score of 0, whereas an AUC of 1 means that the model can perfectly discriminate between the new data and the baseline data and give you a score of 1. Okay, so that's the way you can think of this 0-1 scale. So when you're looking for drift, you would set a threshold somewhere on that scale, say, 0.75, and look to be told when your data has drifted past that threshold. That's what you're seeing in our visualization down below. You start with your baseline data, and it starts to drift over the new periods, and then you're told that drift has occurred once it passes your threshold. Okay, so that's a quick look at what data monitoring is, how it's kind of defined and recorded with Oracle machine learning. Our next concept to talk about is model drift, which again is quite simple on its face. It's just the gradual degradation in prediction quality of a model over time. And there's two main ways that this can happen. The first is data drift, which we just talked about, and the second is concept drift. Data drift makes sense. A model is trained on data that looks a certain way. As that data starts to shift and look different, the quality of its predictions might degrade. Concept drift is a little more complicated. It's the idea where the goal we are trying to predict has changed. So I like this visualization on the right to kind of explain the difference between these two causes of drift. So say you have an original machine learning model, maybe represented by this catapult. Your model is perfectly calibrated, like this catapult is perfectly calibrated to shoot these projectiles into the basket, right? The projectiles are your input. Given that input, it's calibrated to get the result you want, putting it in the basket. But say data drift occurs in your model. So the inputs to your model are different. In this case, the inputs to our catapult changed. These projectiles, they might be lighter, more heavy, whatever it is, but your catapult is configured to throw, a certain input and put it in the basket. When that input changes, you no longer get the result you want, right? And then looking at concept drift. In this case, your inputs are exactly the same. Your catapult is still calibrated to do what it needs to do. Your model is still calibrated to get the result it's supposed to. But what defines that result is different, right? Our goal is different. Our goal is up higher now. So we're still achieving what, was defined when the model was trained, but that goal is different now, and therefore we're not getting the predictions we want. Okay. So I hope that helps you understand what concept drift is a little better. We'll have another example of it in a couple slides here to get a better understanding of that. So now that we understand what model drift is, we can talk about model monitoring, tracking the prediction quality of our models over time to look for that performance degradation. Again, we're working with a baseline data period and the new data periods. And this time, instead of looking at bivariate interactions and such, we're looking at the performance metrics of our models. It could be accuracy or F1 for classification, mean squared error, mean absolute error for numeric prediction, for example. We also have the 0 to 1 scale this time again. This time it's calculated by looking at the difference between the baseline and the new data accuracy metrics or performance metrics, and then scaling that by the baseline metric. Here's a good time to talk about the fact that data monitoring is a prerequisite to effective model monitoring. And that has to do with the fact, in our previous slide, we talked about how data drift is one of the main causes of model drift. So when you get your model monitoring alert that drift has occurred in your model, the first place you can go is to your data monitoring results to see if your data has also drifted. This really helps you get to the root cause of your model drift. You can see if it's because your data changed, or if not, you can look to see if there's some concept drift that happened to cause your model to drift. Looking at our visualization down below, we can kind of see what this model monitoring looks like and the drift and a score and what that looks like. We have our baseline time period with our given accuracy metric scores. And over time, those metrics degrade until they go below our alert threshold that we defined. But this visualization also brings up another concept that model monitoring can be used for, which is the idea of a champion score. So here we have two models. So we could have multiple models in production to solve one business problem. And at any given time, we would only want to use the model that has the highest accuracy metrics. So of our two models, M1 has the highest metrics at baseline, and then in period 1, M2, and then M1 again, and then they both go below the alert threshold. So this is a way to maximize the accuracy of the predictions you're making in production by monitoring your models, understanding at any given time which models have the best accuracy metrics, and then using those models. So that's a good practical application of model monitoring. So next, we're going to talk about an example use case for model and data monitoring, how a real-world company might, use these concepts with one of their production models. So in this scenario, say we have a bank and they use a machine learning model to pre-approve people for loans. Their ML team sees that their model monitoring results tell them the quality of this model is degrading, so they look to figure out why. They first go to the data monitoring results, and those results tell them that the customer's data hasn't really drifted. So this company then looks to concept drift to try to understand the cause. So they think about the recent business environment changes, what might cause this concept to change of who is somebody that is good for a loan. And they note that the economy has improved as of late in this situation. So taking that into account, the bank's strategy has changed to approve more people for loans than they would before. But their machine learning model is still trained, with the previous information in mind, and therefore is not approving as many people as the bank would like. Okay, so in this case, the concept of who is a good borrower changed due to changes in economic conditions, right? So that concept changed. Because of this, they retrained their model, taking the new economy environment into account, and have a model that approves the right rate of people. So that kind of walks you through the use case of seeing that your model is degrading, looking at the data monitoring results. They may tell you that data drift has occurred. If not, you can start thinking about what concept drift might have occurred in your situation. Okay. So moving on here, we can talk about why data monitoring and then why model monitoring are important. First, we've already touched on how data monitoring is a prerequisite to effective model monitoring, right? When you see that model drift has occurred, you want to go and see if data drift has also occurred, get to the root cause of why your model is drifting. But this is not the only use case for data monitoring. Data monitoring also stands alone as a useful tool outside the context of machine learning. If you think about it, there's a lot of applications where you could have a set of data, and when a significant amount of change happens to that data set, you want to do something, right? For example, maintaining data quality. If you see that drift has occurred in a data set, you might want to look at it, make sure that the correct values are being inputted into that data set. Maybe analyze data when it passes a threshold. If some of your customer data changes to a certain extent, you may want your marketing team to analyze that, understand the changes that are happening with your customer base. And really just the general use case here is to perform any action when data passes a certain threshold, right? So data monitoring is useful outside of the context of machine learning. Moving on to why model monitoring is important. We've kind of touched on this a little bit already, but it's key to understand the quality of your deployed models and doing so on whatever basis you see fit, hourly, daily, weekly, however important it is to you to look at that threshold. You also want to know why your models degrade. This is really model monitoring and data monitoring together. Again, we talked about identifying if you're looking at data drift or concept drift. And model monitoring really just helps you gain awareness of when a production model degrades and might need to be replaced, so that your organization can be proactive, make sure there's always an acceptable model in production, and maximize that business value. This is, again, where that idea of a champion model might come in, always using the best model with the highest accuracy at any given time for your business. And you kind of see this over here, right? You have your threshold of acceptable performance for your model, and you're just constantly retraining or putting a different model into production when it approaches that threshold, maximizing the business value of your models. All right. So we've talked about data model monitoring in general for a bit here. Now we want to dive into the Oracle machine learning context, right? How does this work through OML services? So first, taking a general look at OML services, this is something that extends the functionality of OML on ADB, supporting things like model deployment and lifecycle management. Going down the list of things you can do with OML services, you can score machine learning models, create scoring endpoints. You can also do classification and regression with third-party models that are in ONNX format. There's also cognitive text and cognitive image functionality. And then in the list of things that are coming soon, we have asynchronous jobs for batch scoring, and then data and model monitoring, which we're obviously talking about today. Okay, so looking at the different operations you can do through the REST API interface of OML services, you have some different categories of requests. Your request here to get a token to access OML services is key, and we'll talk about that a bit. And then, you have your repository requests for storing models, deployment requests for creating the endpoint and scoring, your asynchronous job requests, which is some of what we're going to get into today, because again, model and data monitoring are asynchronous jobs. So we'll walk through creating some of those, and then your cognitive text methods as well. All right. So when you go to use Oracle Machine Learning Services, the first thing you need to do is to get a token to access OML services. You do this by sending a request to your database. You send it with your username and password credentials to this OML user's endpoint, and you'll be returned a token. And using that token, you can authenticate and send requests to OML services, right? So getting this token is your first step in any OML services task that you're looking to do. As far as getting the URLs that you need to send these requests, you can look under database actions for your database. If you scroll down to the bottom, you'll find your OML RESTful services under related services, and you can copy the URLs that you will need. Looking at the structure of these URLs, so it starts with your tenancy ID, your database name, and then your data center region. And then this root domain is something that's always going to be the same, across any instance. It always ends with oraclecloudapps.com. So looking at how to request a token. So we're going to be showing some curl requests here. When working with OML services, we suggest that you use a REST client. For example, Postman is something that Sherry is going to be showing off for her demo here. It just makes sending these requests, storing environment variables a lot easier than it would be just working with the terminal. But anyways, we're going to show this with a curl request here. So again, we're requesting a token used to access our OML endpoints. So this is a post request. As you can see, we have our username and password for authentication, right? We're sending it to that OML users path. So once you have sent that request to get your token, and you have your token, you could submit an asynchronous job request, like a data monitoring job request. So this request is broken up into 2 slides here because it's quite a big request. You can see the job properties will continue on the next slide. But with this request, we're looking at a post request to that OML mod endpoint. This is a variable holding the token that we had just got with our previous request. And the first thing you have to define for an asynchronous job is the job schedule. And here we are just defining when we want our job to start running, to end, and the number of times we want it to repeat within that start and end date for running. You can set your frequency, for example, here to run daily. You can also set the max number of runs. So this just defines how you'd like your job to run. And then our job properties gets into the details of our data monitoring job. Things you need to specify include a name for your job. This job type defines it as a data monitoring job. Your output data names is the name of the table that your results will be sent to when this job is finished running. Then you need to define your baseline and your new data. Just like we talked about in defining data monitoring, you need to declare these data sets that are going to be used. You also set your threshold. Again, this is the line that needs to be crossed for it to be considered that your data set has drifted. And then these next three parameters all go together, being the time column, start date, and end date. With these, you can define the time period and the new data that you would like to be monitored. So in this case, we're starting in 2020, ending in 2021. Say if this Iris DM new data set was like from 2020 to 2022, this start and end date would make sure that only the years from 2020 to 2021 were actually monitored. And then this time column is the name of the column that holds these time values within the data set. And then the last thing we'll see here for our data monitoring request is the feature list. So data monitoring is something that happens on a column by column basis. Important to understand that you're not monitoring just drift of like the overall data set, you're monitoring drift at an individual column basis. So you'll see this when Sherry does our demo here shortly, but you will have drift scores defined for each individual column. And here you can choose specifically which columns in the data set you would like to be monitored for drift. Moving on to a model monitoring request. This first part of the request is pretty much all the same. Again, we're using our token for authorization, and the job schedule is the same between these requests, right? Setting our start and end date, how we'd like it to repeat. Looking down at the job properties, we'll see some differences. First, our job type is model monitoring, of course, not data monitoring this time. We set a name, output data table again. We also have to define our baseline and new data and threshold. You won't see a difference till the bottom here, where instead of listing the columns that we'd like to monitor, we can choose a performance metric on which our models are going to be monitored and scored on. And then we can define the list of models which are going to be monitored. So a lot of times you'd just be monitoring one of your production models. But again, if you have a setup with a champion score, like I talked about earlier, where you have multiple models in production to solve one business problem, then you could list those multiple models here to all be monitored together. So once you have submitted your model monitoring, your data monitoring request, you can list all available jobs to see that that job was correctly created. On job creation, you will receive a job ID in response. So you can use that to see your job in the list of all available jobs. And this request is done with a GET request, again, to that OML mod endpoint, looking at V1 jobs. You can also look at the specific details for one job. This goes to the same endpoint, but just with the job ID I just mentioned added to the end. And this will show you a whole lot of information about your job, such as all the parameters that were defined in the job request. Also, if a job has run at least once, it'll give you information about the last job run, such as if it succeeded, if it didn't succeed, what kind of error it encountered, and such. All right, and then this request is the same for data or monitoring jobs. There's no difference when it comes to getting the job details. All right, so I've talked about what data and model monitoring are in general, talked about them in the OML services context. Now I'm going to hand this over to Sherry to give us a demo of these features.
Okay, thank you, Miles. Okay, so you're looking at OML notebooks, and it's a Zeppelin-based notebook interface. And in this notebook, I'm going to walk you through a data monitoring workflow where you authenticate the database user and get the token, create a data monitoring job, view the job details and output, and then some optional steps where you can update or delete an existing job. So I'll be showing you the curl commands in this notebook that you would run in a terminal window, either Linux or Mac or the OCI Cloud Shell, or even another REST client like Postman. So to start, you need an access token, and to get the token, you'll send a POST request to the Autonomous Database token endpoint, and you'll provide your OML username and password and your OML service URL, which you can get from the database actions like Miles mentioned. And once you have the token, you can submit your data monitoring job. Okay, so this is the list of parameters for that are available for submitting the data monitoring job. And I'll just go down to the curl command that you would run. And some of the required inputs are the user provided job name, the job type, which will be data monitoring, the output table name to store the data monitoring results, the baseline data to be monitored, the new data to compare to the baseline, and you can specify a job start and end date in the job schedule. And if they're not provided, the job will run immediately. You can also disable a job upon submission and enable it later, provide a job description, specify your own drift detection threshold different than the defaults among these other options. And when your job is submitted, you will get the job ID back. And because the job runs asynchronously, it will run on its schedule, and you can use the job ID to view the job details or perform any actions on the job. To view the job details, I'm first exporting the job ID to a variable and then just sending a GET request with the job ID to the job's endpoint. The response will include all of the job details, including the parameters for the submitted job and all the defaults, the job status, which will indicate that the job was created, its state, which is scheduled, along with the number of times it has run and the next run date. If you want to update a submitted job, you can do that by updating any of the parameters listed here. So for example, when this job was submitted, we chose to monitor sepal length and sepal width only in the feature list. And one of the updates here is to monitor petal length and petal width as well. If your job is disabled, you can, if your job is enabled, you can perform actions on the job like enabling it. The job, when it's submitted, is enabled automatically, which means that it will run on the schedule that you specified when you submitted the job, unless it's updated to another state like disabled. And remember that if you want the job disabled upon submission, you can do that too. There are other available actions like run to test the job outside of its schedule, or you can stop a currently running job. So you can see here the action is disable. Okay. So now when you want to view the data monitoring job output, you can look at the output table, and the full name of the table is it contains both the job ID and the output table that you specified. And this paragraph queries that output table associated with this example. It has information for the baseline time period, the new data time period for each of the dataset features being monitored for drift. Miles mentioned this. Some of the columns are empty for the baseline rows because monitoring is only done on the new data and not the baseline data. There are start and end times for monitoring in this table, whether the metrics are from baseline data, the threshold value that is used to decide the has drift value, which indicates whether a drift is detected, the magnitude of the drift, and the names of the monitored features, which are the predictors. If you want to delete a data monitoring job, you just simply send a delete request to the job's endpoint with the job ID. Okay, so let's take a look at the model monitoring workflow now. Okay, so OML Services model monitoring supports classification and regression models, and the performance is tracked using model accuracy metrics. The balanced accuracy is the default for classification, and mean squared error for regression models. The workflow is very similar to data monitoring. You're going to get your token, and then you can create your model monitoring job. So we're getting our token, and here we'll create the model monitoring job. So to do this, you need your model ID. And the model ID would have been previously deployed using either the AutoML UI in OML notebooks or from a REST client. And once we get this model ID, which is shown right here, we can submit the model job with the job type model monitoring. And this is what the curl command would look like when you run it in your terminal. So we pass the model ID or list of model IDs to the model list parameter, choose the performance metric, define the threshold for the drift trigger, and all the other parameters listed here, which are the similar for data monitoring jobs. Okay, so you're getting your job ID back. You can view the job details just like you can with data monitoring. You have the ability to update a job, new models or a new drift threshold, and then you can view the model monitoring job output. So when we query the table containing the model monitoring output, we get the start and end times for the monitoring and the performance metric, the model ID for the model being monitored, whether the drift has been detected along with drift magnitude, the model metrics, including the prediction statistics. And you can also update the model with different actions and delete the jobs as well. And we'll make these notebooks available after the session, and the notebooks actually contain code to reproduce this particular example. So now what I would like to do is just show you how all of this works with a Postman. Okay, so this is the Postman interface, and this is a REST client that has a user interface, and it's actually really nice. On the left here, you can see this is called a collection, and it contains all of the post and get and delete calls that we showed inside the notebook, but you can actually run them here. And so the first thing that we need to do is get our token. And what we've done is set up an environment with our OML username and password and our OML service URL so that we can actually get the token back, and then we save it to a variable, and then we can use it for the rest of these actions, like to create a model monitoring job. Inside the body in Postman, you can put your options for the job schedule and the job properties, just like we saw with curl. I have my model list. So I'm going to create a new job, and I just need to hit the send button, and I get my job ID back. I can also create a data monitoring job if I want to. Job type is data monitoring, and I have, I specify my output data and the feature list. And when I hit send, I'll get a job ID back. If I want to list all of the jobs that I have available to me, I can do that as well. I just send this get request to the jobs endpoint and use my OML service URL, which I've saved to a variable. And then I can see in this this pretty tab, it gives me the pretty printing that shows all of my jobs and the job details. Postman also has this visualize tab where you can actually, over here in these tests, you can set up the output to be returned in a tabular format. So here you can see the job name, the job ID, and then other parameters that are relevant to each job. If I want to look at the job details for a specific job, I just need to pass the job ID to the jobs endpoint, and then you get all of the job details back for this particular job ID, which is saved in my environment. Similarly, you can update your job for data and model monitoring. And here in the body, I'm updating the feature list and the drift threshold. For model monitoring, you can add more models here or replace the single model. And then, of course, the job action, if you wanted just to run a job like this model monitor or data monitoring job outside of its schedule, you can do that. And you won't get the response body is empty, but you will get the 204 error if it's exceeded. And then you can delete your jobs, either data or model monitoring, by sending a delete request with the job ID to the jobs endpoint. So that's all that I wanted to show you today. Back to you, Miles.
Thank you, Sherry. So this brings us to our second poll of the day.
Okay, so thanks, Miles and Sherry. For the second poll, how likely are you to use data or model monitoring in projects going forward? Do you plan to use data and model monitoring in future projects, and perhaps only data monitoring or model monitoring? Do you need more information before you feel you can start using these features? And also, perhaps you don't need to use this level of functionality yet. So give us a sense of where you're at in the model monitoring space. Looks like we've got so far about 60% of people saying they plan to use data and model monitoring in future projects. Balancing out now, we've got about 50-50. They plan to use it. 50% are saying that they need more information before they can start using the feature. We have a slight edge for data monitoring over model monitoring of those who are just going to use one or the other. And only a few folks don't plan to use these features at this time. So, all right, thank you very much for your response to the poll.
All right, and that brings us to the end of our presentation today. So now we have some time for any questions.
Yeah, we've had several in the Q&A, and we can review those. I think one question that came up is, since we were showing the curl commands in OML notebooks, can we use that in OML notebooks?
No, that's for illustrative purposes only. You can use, well, you can actually use Windows curl. You could use Linux or Mac curl, or you can even use the OCI Cloud Shell if you want to run the curl commands there.
Great, thank you, Sherry. And another question, while we're using the REST API today, do we have any plans to provide any type of UI support for monitoring jobs? And the answer to that is yes, we do have plans for that. That's something that we can look forward to in the coming year. So stay tuned, and we'll give you an update on that as it occurs. All right, so let's go back to just a few questions that we had in the Q&A. One involved data drift. Is it measured always in respect to a particular ML model, or is it possible to measure data drift on its own? And Sherry and I were commenting how yes, the data monitoring can be used in combination with a specific model, but it's perfectly legitimate and in many important use cases for leveraging data monitoring completely independent of the machine learning process. So you may just want to use that to understand how your data is changing, how it might be affecting your applications. And if data issues, the data quality issues are coming into play, you can then proactively address them rather than waiting for some user to highlight that. Let's see, another question. Can we define data monitoring jobs in an incremental way without setting fixed data range? Something like the job should monitor all new data inserted into the database from the last run. Boriana, would you like to comment? Because you had responded to that one.
So it's supposed to work as the data becomes available. You can start with an initial period, and then as you add data, if you schedule the job to run periodically, it would be picking up the new data. And if you add data to past periods, you have the option to recompute the past, or even if you want to remove data, which for whatever reason becomes irrelevant, again, you can recompute. You can choose your analysis period from when to when. So not everything is updatable once the job is running, but things related to what period to consider and what is the decision threshold, whether to recompute or not, you can change them at any time and get fresh results.
Thank you, Boriana. Another one, are more technical details regarding data drift and model drift available? Like, what's the algorithm and the like? And Boriana, back to you.
Well, I think within Oracle, we could share our specs. I mean, the reason we don't kind of document this in greatest detail, because everything's subject to change, the methodology, we expect to evolve it, but we can share internally with people from Oracle how we did it and share specs.
Okay. And will the data drift monitoring detect changes in correlations between two variables, or does it look at a single variable only? Brianna?
No, it is a holistic view. That's why I think Miles explained it in great detail. We actually use machine learning to look at the data holistically. We use complex models. Currently, we use a random forest model to and based on what that model finds, we kind of report which features are important and give you insight where it's coming from. We have the univariate statistics just because we think people want to look at those, compare. They're also easy to interpret, but we also offer bivariate statistics. So again, for visualization. But the main thing is to get the complete picture. We are allowing a machine learning model to pick up the interactions, and then we explain the model, the interactions it found.
Thank you, Boriana. And for our last question, are the REST endpoints available on-premises database also? And Boriana and I both chimed in that OML services, they operate on autonomous database shared only today. It is part of OML services, this monitoring capability, and so it is tied to the autonomous database shared instances only at this time. So unless there are any further questions, I'd like to thank Sherry and Miles for their presentation and demo today, and Boriana for helping us with the Q&A. And with that, until next time, thank you all very much.